starting. Okay, now starting. So let me start our proceedings for today. So we've gathered here as part of a community of practice on qualitative comparative analysis, and the topic that we'll be talking more today about would be robustness analysis of the QCA results. Before anything, we first have to acknowledge the traditional owners of this land where Swinburne, our university's campus is, and where I'm sitting right now. They are the traditional custodians and owner of this land. They are the Wurundjeri people of the Kulin Nation, traditional owners of this land on which Swinburne Australian campuses are located in Melbourne's east and outer east, and pay our respect to their elders past, present, and emerging. We also respectfully acknowledge Swinburne's Aboriginal and Torres Strait Islander staff, students, alumni, partners, and visitors. With this, let me introduce you the agenda for this workshop, or this talk. I keep saying this workshop, this talk. So these are the 4 points that we'll cover. The first, because this is one of our first meetings for this community of practice that we first started last year, late last year, and then we got into the process of organizing a MS Teams page, getting approvals, and all those sorts of things. Also because some of the attendees have a high level of expertise in QCA, while some are beginners. So what we'll do is first we'll briefly describe the background. How does QCA work? And then we'll go to the main topic, that's robustness analysis. And fourth would be any topic that would be interest to anybody, and also future plans. Now, going forward, so the idea for this community of practice came because it's a new method. It still is not as established. There are some resources here, but more often than not, the people who work on this method, they don't have much company within their own organizations. Like in our university, there are not many people who use this one. So how I started doing that one was in 2016. I learned it, and there was a lot of self-learning, and the learning took much longer than it should have taken, mainly because there was not much of support to me. Then I started publishing this one, and then even then, when the reviewers' comments came, I was struggling. Then I came across Eva. I wrote to her. She kindly provided me a lot of support that eventually helped me to publish my paper, and others as well. I was expecting Fawad to join as well, and Fawad also helped me, and we were talking on phone as well, some meetings as well. So the idea was that because there's not enough support for this, for the details, how to operationalize, define the best practices. So the idea was that we start an informal gathering where we learn from each other. And I've just put the community of practice formal definition. It's a group of people who share a common concern, a set of problems, or an interest in a topic, and who come together to fulfill both individual and group goals. So primarily, this is for us, furthering our collective QCA knowledge for publishing success. And this objective was when last year we did a small survey within our people who had some interest in QCA, and we asked them what's number one priority, what should be the number one priority for this community of practice, and they responded that it should be that we should be able to publish our papers using this method. So that became our objective, so furthering our collective QCA knowledge for publishing success. So in the same spirit, the thing that we've recently experienced, and I would agree, is that now if we submit a paper based on QCA, there's a lot of emphasis on the robustness analysis of your findings. So we'll learn something about that today. And as I mentioned, prior to that, we'll just cover the basics of QCA. And after this, I'm doing more of talking now, but when I finish this one, we can start we can open the floor and we can learn from each other. So essentially, the QCA background, first question before others join, I was having a chat with Hassan. So I'm not sure about other people's background, but my background, Eva's background, Hassan and others, we're more quantitative survey researchers. So we'll be talking mainly in that spirit, but later on when we have a mutual discussion, we can bring in the qualitative studies as well, and we can try to answer those or inform others with that qualitative background as well. So essentially, how does a QCA study starts is those who have done or quantitative survey-based studies is that you take theoretical construct, you operationalize that through survey questions, and you do some validity tests, reliability test. From in that respect, a QCA study is very similar to a typical survey study where you do have Mayer's validation test. So you have to do that, survey adequacy test as well. So all this thing is very similar. The difference come when you start using regression or when you start using structural equation modeling. From there onwards, the difference between QCA. So you start doing QCA after you've done the Mayer's validation. Okay, Hassan, this was your question, right? So still the validation of Mayer's, everything is same. You first have to ensure that your data collection method was adequate, so non-response biases and all those tests you have to do. Then you also do the reliability test. After you have done the reliability test, what you do is there are two ways, as now we know. We either average each construct, or we use the factor scores as well. So people do use both. So you would have to justify whatever you want to choose. But once you've got that individual score for each of the theoretical constructs, what you do is you calibrate that. That's the first step in the calibration process in the QCA. And that's the most important process. The key principle that guides the calibration process is what you see here on the screen is that half conceptual and half empirical process of identifying thresholds that meaningfully represent differences in kind and differences in degree. So this is a key statement. And it's directly linked to the robustness analysis as well, because your results are largely dependent upon the type of calibration principles that you use. So it's a very important step, and actually determines the type of output that you would have. We'll talk more about that when we'll be talking about robustness analysis. But the first step to begin, just to explain the newbies about how QC operates, is that once you've got your measures that are validated, you've got Mayer's scores, then you have to calibrate that on a scale from 0 to 1. And the principle that guides is half conceptual and half empirical. A little bit of more details when we go further. A very basic example is FIS, Academy of Management paper 2011. What they did was, once they've got each theoretical measure, full membership means that your the condition is part of or your response to that survey question or to that theoretical construct is member of this theoretical construct. So what they did was you have to identify three thresholds: is full membership, non-membership, a crossover point where you move from non-membership to full membership. And what they did is a Likert scale. So these are the points on a Likert scale: 1, 3, 5. 1, that means that it does not belong to this theoretical measure. 5 means that it's a full member. 3 is a 50-50 thing. And it's a continuous scale. This is what we'll have in calibration. There are other things as well, and we need to talk about those because when we talk.
Can we ask question or we ask question at the end?
Oh, please do that. Please do that. Yeah. Go on.
For here, in case that we don't have any like a 3, 1, 2, 3, what should we do? Like we want to do calibration, we don't have any 1, 2, 3, and the response starts from 4, 5, or 3, 4, 5. Let's say
you don't do manually. What you do is there are software routines. there's a software that can do it for you. So you do not have to manually identify 3 answers. So it's a continuous scale. So it will pick any value from 0 to 1 based on the corresponding value of 135. So even if you got 3.5 or you got 4.5, it will pick a value which would be corresponding to this scale between 0 to 1. So it's 4ish, and so you, for example, the single value for your theoretical construct is, let's say, is 4, right? And we have used this calibration principle. So it will, because calibration is between 0 to 1, and if that is 4, and if we have picked the crossover point as 3, so your calibration corresponding value would be about 0.6, 0.7. So it will be automatically picked, and they are that's pretty easy. You just feed in the software that this is your corresponding full membership points, this is your non-membership point, and it picks automatically the corresponding value for your calibration.
So it's fine if we don't have any non-membership. It's fine. So we don't have any if you don't have 1 on 2, that's fine, right?
Yes, Eva, please.
And I'm sorry to interrupt, but I think your question is if in your data you don't observe any cases that are not members of the set that you're examining, right?
Yeah, exactly. Yeah. Okay. Yeah.
Well, that might create problems or difficulties when it comes to the minimization. Most of you were probably getting also to that point. You will have a problem when you will actually do the QCA, where you create the truth table and then try to minimize the truth table. If all your observations are members of the set that you are examining, there's not going to be anything to minimize. So then if this is your case in your data, you should think about how you conceptualize your sets, basically, so your variables, because in QCA the variables that you're looking at are actually defined in terms of set relations. And I don't know what is your research on, like what are you looking into?
It's just a question. When
Just
I was like watching the video, it's just a general.
Okay.
Data
Yeah, for example, if you're looking into successful cases of companies that did, I don't know, a specific strategy, and you look at success, then you can think, how do you define success? Does success mean that they have to have answered 5 on the Likert scale, for example? And then you can go and you can conceptualize and say, okay, only 5 really counts as success, and everything that is below 5 is considered maybe less successful.
I see.
So you have to then go and look into your conceptualizations if you really only have
those. Okay.
Yeah,
makes sense. Okay, awesome. Thank you.
Yeah, you're welcome.
Thanks, Eva, for answering this question. And I think it's I don't know why I'm talking a lot. I think I need to, because that's we have to give a little bit of background. But the idea is that we learn from each other. So please feel free to jump in, Eva, please, because I think you're the most experienced one here. So yeah, just quickly to add to what Eva has just said, QCA by its very nature is an iterative process. So once you have chosen this one and then you practice and you found out later on that what Eva has mentioned, then you go back and change these things. So it's an iterative process, right? Okay. Now, there are other things that we need to talk about here. Consistency and coverage. These are the 2 basic parameters that would guide all your analysis. Consistency is essentially, it tells the degree to which the data show consistent relationship between X and Y, causal conditions and outcome. And there's a formula for this one, which I wouldn't go into detail, just describing a high consistency means that the relationship between causal condition and outcome is more consistent. Whereas coverage it assesses the fit of the results to the underlying data. It's like, you can think, some people say that you can think of this as equivalent of R square, that how much of your respondents would fall into or would represent the results that you're getting. So consistency and coverage would be 2 things that you would frequently use in your analysis. Now, this is something probably just to explain, because later on we'll be talking about the robustness analysis. One thing that I just mentioned is 0.8. So these So there's Boolean algebra that's being processed behind all these data. So software would take care of this thing, but they're not overly difficult. You can obtain the same results in an Excel sheet as well if you know the Boolean operations. So this is the consistency measure that I was talking. If it's greater than 0.80, we say that this configuration, which is a combination of different causal conditions, would be part of or would contribute to this outcome. So that's what normally the standard is, 0.80. If it's less than 0.0, then we say that it does not contribute to strong performance. It's the opposite of the strong performance, which will be the weak performance in this case. Okay, once that was the operational details of how QCA is implemented. Number one was the calibration. Number two was the truth table generation. And after the truth table generation, we have got this the final results, the solution. We've got three types of solutions: got complex, parsimonious, and intermediate. What FIS, again, 2011 paper, what they came up was that how to represent our results. There are three types of results, which one to choose. What they did was they chose, they tried to represent these three solutions in a what they call as core and peripheral conditions. And that has become somewhat standard in representing results. So core conditions are those who are part of both parsimonious and intermediate solutions, whereas the peripheral conditions would only be part of the intermediate solution. So that's, you see the bigger circle, that means that these are core conditions and the smaller circles are the peripheral conditions. And general understanding is that the core conditions have got a stronger impact on the outcome. But that's generally how FSQCA results are obtained through the causal conditions. It's more on the operational sides. The concept is similar to what we call as, we identify a combination of inputs that would result in this output, very similar to regression, but how they do it is different. Okay, now we go to the main topic, which is the robustness analysis. And why we think it is important is so up until a few years ago, you pick up all FSQCA paper. What they do is that, okay, here is how we did calibration. Here's our results, and that's it. They do not fully explain earlier papers that what would happen if you change your calibration? What would happen if you change your consistency thresholds? And that actually is a shortcoming. Why I say is that in general research, what we have to do is we have to show transparency, we have to show reproducibility, that others people reading our paper are able to come up with similar research. So that thing was missing in QCA papers. Increasingly, now a lot of papers or reviewers, they are putting a lot more scrutiny on your work. So they ask for what we call as robustness analysis. There are 2-3 papers that you could follow in journal. What you see here is Funari, that's again Academy of Medicine paper. I like this one because they talk in terms of the front end of the paper, the research design, how to conceptualize, how to take your research further. The best practices in terms of implementation, which I've just previously described, there are 2 papers, one from Greg Hammer, the other one was Pappas and Woodside, which is recent in information system domain. And 2 studies that I put here, exemplar studies. Both of authors of both these papers are here. One is myself, and the other one is Lexit. And it's not that we're praising ourselves, but not many studies provide details in additional appendices as Eva has done, or I have done as well. So our paper, if you follow the methods like Eva's and mine as well, you'll be able to reproduce that research for your own data as well, which is important. So all what we will talk, you'll find traces of that from Eva's paper and my paper as well. So that's what is our topic, robustness analysis. Now going to Greg Hammer, they describe what do we mean by a robustness analysis. what we see here is what if we change our inputs or parameters like consistency, like calibration rules, how would it affect the results? That's what the robustness analysis mean. Now, first and foremost, what I find is that if you change the calibration, the whole set of results just changes. It's something that is, to me, is both strength and weakness of this method. Now, in my paper, what I did was I did a lot of spade work in terms of showing to the reviewers that we tried many calibration rules. We tried so broadly speaking, you can put calibration rules into two sets of categories. Number one set of category describes, they follow what they call as what I showed you previously, face work. So one is it's out, it's non-membership and a Likert scale. 5 is full membership. 3 is the crossover point between non-membership and membership. This has been what we call as a very common calibration rule that has been used. Now, whatever used is also I like that one, but it didn't work for my paper. So whatever it was, if you think carefully, the Likert scale actually represents linguistic descriptors. Like if it's agree, it starts from 4 only. So 3 is neither agree, neither disagree. So you cannot really put 3 as a crossover point. It has to be 4 because the agreement starts from 4. So whatever did was she put 3.99 as the threshold. Am I correct, Eva, on that one?
Yeah, that's correct. That had several reasons. On the one hand, is of course like the conceptual argumentation that I looked like what do these scales actually mean in terms of set relations, and if I want to only have companies in the set of successful companies that actually agreed that they were successful or had, I don't know, high service culture or whatever I was measuring, I looked at the linguistic descriptors that as you very correctly put, and said that only 4 actually means that yes, I agree that I am in this set as a case. The other aspect is a little bit more practical. I mean, I did when I didn't use the factor scores as a basis for the calibration for the same reason, because I couldn't interpret that qualitatively. I couldn't make sense of what they mean, and I would have had to use arbitrary calibration rules. So I actually went and I just calculated indices for my constructs. So basically just the mean, and then if you have too many cases that are actually at your crossover point. So for example, like you have a single factor construct and you use 3 as a crossover point, you're going to have cases in your data set that actually answered 3, and you are not going to be able to put them in either in or out of the set. So they are actually going to be some sort of missing values. You cannot actually work with them. And that also creates like more like empirical methodological problems. But of course, the main reasoning should not be, okay, it doesn't work that well. It should be like qualitative and like what was the thought process behind. Yeah, so this is how I went about. But like it was specific to my research, and it made sense for my research and my constructs, and for different constructs, other approaches might make just as much sense.
Thank you. So as further to what Eva mentioned, so 2 broad categories. One what we broadly can call as conceptual calibration rules, where you use the endpoints or the middle point of a Likert scale. It could be 1 to 5, it could be 1 to 7, or the linguistic descriptors as Eva mentioned. That's one set of calibration rules. Another set of calibration rules that we've got is based on the sample itself. Many people use either the median rule or the mean rule. So they take the mean or median as the crossover point. So anything less than the mean would be non-membership, towards the non-membership. Anything more than the mean would be towards the membership of that construct. So 2 broad set of categories. Now, in my work, what I did was I actually experimented with a lot of whatever I could find my hands on. I tried 1, 3, 5 because my 5-point Likert scale. I also tried with what Eva had done, 3.99. It didn't work for me. Why I say it didn't work for me, I'll just show you in the next slide. In fact, I should show you. I should show you here. Okay, so here was the final truth table that we used in our paper. So what you see here, just to explain, putting everything together, and sorry for those who know it, but for those who may need more help here. So when you perform Boolean operations and on your data, you've got 4 causal conditions: TA, that is task autonomy; team diversity; iterative and incremental development; and communication. These were the 4 causal conditions. As per my conceptualization, these 4 causal conditions, various combination of these causal conditions would result in high performance, which I call as strong work outcomes. So that was the truth table. Now, what you see is that these 1, 2, 3, 4 could be combined. If you have that permutation, it's 2 raised to power 4. We have 16 different combinations of these conditions. Now, and 4 of these were not empirically observed, so we were left with these 12 combinations of these 4 conditions. And the survey respondents would fall like the configuration 1 was represented by 61 survey responses. This were 41. So these are survey responses in my case. Now, when I tried different combinations, remember originally we had the Crack-Hammer rule. I really like it. This is degrees in kind and degrees in, what's the print I've got? Degree in kind, and I'll quickly go back. What this said was, so it's a half conceptual and half empirical process of identifying thresholds that meaningfully represent differences in kind and differences in degree. So that's a key term. And what does it mean in practice? I'll just show you here. So differences in kind and differences in degree. Now, you see what you see here are different outcomes here. It's 1, 0. 1 means that it contributes to strong work outcome. 0 means it does not contribute to strong work outcome. If we've got all this as 1, 1, or the same outcome is here, that means we do not have differences in kind. That means your calibration rule won't work. Something that Eva mentioned to the first question that Hassan raised, if your data doesn't have those things. So when you do the calibration, you'll find out that there is no differences in kind here. So you have to go back and change the calibration rule. That I did as well. And then, of course, this is differences in degrees. So what you see here, the differences in degrees, so they vary along as well. So that was number 1. If you got only 1, you're in trouble. If all these are only 1, you need to go back and change it. If you got all 0, then again, you do not have differences in kind. That was one principle. Go back and do it and change it, try a new rule. Another one that I learned actually, and Eva really helped me during the review process. I was continuously writing to her, and she was very kind to have been providing me all the detailed answer. Is what you see here is a star here. It's a high level concept, but it's good to be knowing initially, in early days of your research as well, because it's important. It's a star here. What it tells you is sometimes. So the one key element of QCA is that it is different to regression because it is asymmetrical analysis. Asymmetrical analysis means that the more of one thing, more of input condition wouldn't necessarily mean that, if you reverse it, like less of an input variable would means less of an outcome. So it's an asymmetrical analysis. So what we do is we perform 2 analyses, one for high performance and UW is unsuccessful work or means low performance. It's like reverse analysis. So it's not theoretically or conceptually possible that we've got this one, that this combination would not result in high performance. And if it has the same thing here, that it does not contribute to the high performance, and it also does not contribute to the low performance, right? So that means it's not conceptually possible. In that way, what we do is, or those conditions or those configurations which have simultaneous membership both in the high performance, which is successful work outcome, and the low performance, which is the unsuccessful work outcome. So that's theoretically not possible. So if your results show to you that same condition is there for the strong work outcome, and it's also here. There's one here as well for the reverse analysis. That means that you also have a problem here. If there are many of those conditions, if there are few, like in this case, 2, 6, 8, there are 3 conditions that had the same, or that had contradictory memberships. So what I did was I just considered them for one outcome. I did not consider them for their alternative outcome. So that's also one way to decide on the calibration rule. If you've got a high degree of simultaneous membership of your configurations, then again, there is a problem. You need to go back and change your calibration rules. So what I'll quickly do is, before I invite others to join in as well, I will show you the online appendix that I used for my paper. So that's now also there on the paper itself. Go to the website. It's a separate document. So we explain all the calibration rules. So first we tried with the conceptual calibration principles. So what you will be able to see here, and I provided truth table. So this was ours calibration 3.99. More than 4 would be agreement. That's one principle I tried. You'll be able to see, right? So all 1, 1, 1, 1, 1, 1. So there is no degrees differences in kind here. Again, so there's something not right with this one, so I can't use this one. And then I go further. I tried the first one, 135, 135. So yes, again, there is no differences in kind here. And then I go to the empirical calibration principles that depend upon the empirical sample, like either mean, either median. These are the things. For me, median worked. And I provide all this explanation. So qualitative comparative analysis as a method is iterative. You need to experiment and show a lot of options that you tried and report that. As long as you're doing that and being very transparent, you've got a good chance of passing the review scrutiny. So that's, and I'll go back to the next thing that I was talking about was the simultaneous membership. So even for simultaneous membership, the reviewers asked me how we call that resolving contradictory configuration. So contradictory configuration is a configuration that has a simultaneous membership in both presence of an outcome and the absence of an outcome. So what you see here, and I try to explain that there is a principle called proportional reduction in inconsistency. This is an additional new measure. Some people say that any configuration which has a PRI score of less than 0.50, you should not use that one. Then some studies say, okay, you go back and analyze individual cases. So we call that as a deviant case analysis. I used both. And based on that, I was able to resolve, which I showed you in the earlier slide. So this is the whole explanation that you would be able to read yourself and make sense of that. But this is the deviant cases analysis, the one that I was referring to right on the boundary line, neither here, neither there. So that's something that needs further probing as well. So with that, I think what I've done is I've tried to explain the robustness analysis based on calibration principles. Any questions here, or Eva, you would want to jump in? And we've got Andres as well, who has had some experience with this one. So now I think we should move on to more of a discussion. That's the original purpose of this, Kelly. Over to you guys. Thanks.
Thank you very much for this presentation, etc. And I had a little bit experience of this, and this was very helpful. I actually don't have any particular question regarding this topic here, so I can jump in later on. I had exactly this. Maybe I should present what I've done so far. I've only done one QCA paper that we have submitted to the supply chain field, so within last mile distribution. So we submitted that to the International Journal of Physical Distribution and Logistic Management. It's an ABS2 ranking journal, so it's a good journal for us that's new. There has not been so many QCA's studies in our field. So we actually did not get so many questions about the method. We had a fairly long method part. We actually had much longer from the beginning. Then we had to cut it down since we only had 8,000 words. So I have some other questions, but I will wait.
Okay, thanks.
Yeah, I have a question. I mean, also not necessarily regarding the robustness. I mean, of course, it's what you said. You look into different, because in the end there are two places or like two spots in the QCA process where there is a lot of discretion, let's say, for the researcher, and you have to justify these decisions, which is the calibration rules and the consistency cutoff for the minimization of the truth table. And this is exactly how I also did it, like with showing, okay, different calibration rules in a certain frame don't change the result. Of course, if I change the calibration so that cases actually change membership, then
Yes.
of course it is also to be expected that your results will change. So this is also how you can argue to say, okay, the changes that happen are not unexpected. But if I suddenly say that successful cases are also the ones that just say that they are at 3 or somewhat successful, also counts as successful cases, then you of course expect to have different results than when you say only highly successful cases are considered successful in my research. And the same for the consistency threshold. If you change it a little and everything falls apart, then you have a problem. But of course, if you change it a lot, then and you should maybe also just try to play around if you have like in your truth table different alternatives and you see, okay, the PRI drops at a certain point and I have two different alternatives where it would maybe make sense to put the threshold to try out these different options. And if it doesn't make a difference, then like go maybe for the lower to have a little bit more leeway. Like you can play around with that a little bit as long as you make it transparent. If I may, I have a question, maybe a little bit going back, as I saw you use the FSQCA software by Reagan there. This is the table with peripheral and core conditions.
This one? This one?
No,
this
one with the
one.
peripheral.
Yep.
No, the peripheral and core conditions, the solution actually.
Yep.
This one, exactly. How do you like interpret the difference of peripheral and core conditions? Like, like, because is it really that they are causally like more relevant because they are present in more of the solutions? I find this always a little bit hard to interpret. I remember that I was also talking with Fis about it at one workshop, and he couldn't like really give me an answer either. He actually told me that he wouldn't do it again like that. So how did you make sense of this?
Did he say that he wouldn't do it again?
Yeah. Because
everybody else is doing this one, right?
I know it has become standard, and particularly also using the FSQCA, like the Reagan software, which actually produces these kinds of solution tables. And this is what I also thought. Okay, I have to look into this, and I couldn't really make sense of it only by looking at the results. And I asked him, and he said, yeah, I wouldn't necessarily do it again because but it has become standard. So I wanted to ask you, how did you make sense of it?
Okay, so okay now. I must confess that I also, my problem with this one is, so it makes sense to a degree, because depending upon the options that you see here, right? Depending upon where was this one, right? Where was this one? Where is that? No, I've removed that one. Okay, so depending upon the theoretical directions that you choose, right? Presence. So what happens is, from my experience, is that depending upon the directional expectations, these three solutions would become actually two solutions. If you pick, or if you either complex would be very similar to intermediate solution, or parsimonious would be very similar to intermediate solution, depending upon your theoretical justification, directional justification. So what I normally do is I do go with prior, if they were an individual condition, how would they going to act that from that perspective. So I do note that parsimonious becomes somewhat a subset of intermediate solution. And so these ones are common in both. Now the problem is with these smaller circles. Now, an impression that you might get is that these smaller circles are less important. They are less important as per FIS condition, but these two conditions are stronger. They've got, so what FIS says is the same as you mentioned. So they've got stronger impact as compared to the peripheral conditions, but that does not mean that peripheral conditions do not have an impact. So that's what I also feel, to a degree, that this one, that diminishes the importance of, let's say, team diversity in as the causing that outcome from that perspective. But as you mentioned, it has become a standard. Now, if we just reproduce intermediate solution, then probably this differentiation wouldn't be there, right? Because a lot of papers also reproduce just intermediate solution, because that's a compromise between both complex and this one. In that case, there wouldn't be no big and small circle. Everything would be of the same size, because all these conditions are present in the intermediate solution. So that's one way out as well. But in any case, whatever we do, it depends, your paper ends up in whose hand. And if they are a fan of FIS representation, which has become mainstream. So yeah, so I agree to your point to a degree, that if you just use intermediate solution, it keeps things simple. It just doesn't differentiate between the relative importance of these two peripheral and core conditions. But that was what FIS originally thought, to make some differentiation between which you thought to be common in both intermediate and parsimonious. And we are just part of parsimonious, because parsimonious is subject to certain directional expectations, some sort of input that you give to the software. But something that probably we need to be talking continuously. Let's see how next few things. I'm inclined to, just to keep it simple. This is what I've got this in my mind. Yes, keep things simple, then standardization as well. So yeah, it's a bit of a trade-off.
Yeah, I've done the same way as you said here, but I understood also when I read that there was a big discussion about if the core has a bigger influence than the peripheral, at least on the articles I read. So, but I have a different question. I know I've already asked this one here to you. It was one of the feedback, in principle, the only one we got regarding if somebody has a good article I can refer to, that we got on our article regarding the method, was to have a bigger discussion about number of cases. And I know that we discussed this Mark's article from 2010,
yes.
but
Solid.
No, and let's discuss the crisp cases, and we do a fuzzy. Is there anybody that has any kind of reference or article that we could read more about how many cases is suitable for fuzzy studies, depending on how many conditions you have, etc.? It's not a major topic, but it was one of those small things we got from the reviewers.
Now, before I ask Eva to share her thoughts, I've got certain opinion about this one, which is, I'm not sure if it's going to help you. To me, and I've used that marks as well, right? You sometimes have to respond to those comments, right? And I don't think, it's a great justification. It's a different thing. It was an altogether different thing. One of the things that I think for server responses, it's not a big consideration. as long as you can show the, because you establish, reliability of your measures through, it's more of a, in terms of survey research, it's more in terms of data collection adequacy, how much responses you needed, and you need to have a measurement model for this. So in that case, that's partially addressed. Now, what Andreas has done is not, it is survey, but it is not like theoretical measures. It's a bit different. Like it's more of a objective measures that you got from there, right? So you didn't do any validity test, Andreas, did you?
No.
No, it's different, right? It's not like a theoretical measure. For that, yeah. One thing that I can tell you, if I were to review, if the number of responses are a lot more than the causal condition, then it is not a concern to me. But I do not have any answer as such. What about you, Eva?
I'm looking for the chat to post a paper also by Greg Hamer on large N versus small N QCA. Maybe you also know it, Andreas. It's from 2013, but for some reason I don't find the chat at the moment.
Okay. Yeah, no, when you okay.
I don't, off the top of my head, I cannot tell you the content of this paper. It has been a while since I read it, but I would agree that the strength of QCA is that it does not really depend so much on sample size. I mean, yes, of course, you have to have certain observations, but if you look into where it's coming from, which is political sciences, there you sometimes really just have a handful of cases because it's restricted to, I don't know, democracies in the Western world that they are examining as their cases. So the strength lies in being able to do analyses with a relatively small sample size. But in my perception and knowledge and experience, there is no limit as to how many cases you have. So
no, I think I have read that. Now it's a long time ago since due to the summer here in Sweden, etc. It's like 3 months ago. But I also believe that I read somewhere that if you have too many cases, that also makes it much more complex and is not either too good.
Well, if you have too many cases, you might lose a little bit the case intimacy that you theoretically would want to have in QCA. It also kind of depends maybe who you ask.
Yeah.
But in its core, it is a case-based method. So if you have, for example, contradictory truth table rows or simultaneous subset relations, or if you look at your XY plots and something doesn't make sense and you have cases that are somewhere where you would not expect them to be, if you ask Schneider and colleagues, so this school of thoughts in QCA, they would tell you that you have to go and talk to these cases, like to either go and have interviews in the company if your cases are companies, or further go into the data if it's countries or whatever. And of course, if you have a very large N study, you cannot do that anymore. Because they're actually anonymous. Like you don't really know who is actually in your cases. And also the XY plots at some point don't really make sense anymore because the dots are too many. And so you cannot actually identify which are your deviant cases, as Mohsin also noticed. I don't know if you got other critical feedback because, maybe there are also developments that I have missed in the past months regarding the sample size discussion.
Yeah. No, it was just, as I said, some of our reviewers did not know QCA that well. And some even admitted they haven't seen it before because it's very new in our field. So, so thank you.
Good. Yeah, I think in conclusion, to be a sample size, when they first, and I've got actually, I can put the link later on as well, the same 2013 paper that it was book chapter.
Perfect.
Probably, Eva, it was a book chapter, something like, isn't it, right? The small.
Yeah, I think it's a book chapter. It's called The Two QCAs from a Small N to a Large N Set Theoretic Approach in Configurational Theory and Methods in Organizational Research. Although it has volume and page number, maybe it's like a continuously published methodological outlet. I have not seen it before.
Yeah, well, yeah, maybe. So what I'll do is I'll post that in. So if you've got access to MS Teams, right, I'll post those resources. So one of the purpose of this thing is, sometimes you cannot share those papers, but here, if you publish something, you can share in the small group. You're allowed to share to a selected group of people. So we could do that one as well. The same paper I can share as well. So yeah, so in conclusion, I think sample size originally in the same time period when they wrote this paper, people had some issues or some questions, and they said, the spirit of qualitative nature of QCA is now not fully is supported by the large sample size, as you mentioned. But now it has become a bit of a standard. Actually, the more recent applications are in large sample size than small sample sizes, since it has moved from its origin of political science or sociology to business. I think it's more now favoring large sample size.
Good, thank you.
Let's move to other participants here. You got any questions here or anything? Or yeah, we've got this luxury of having some really experienced people here. So and ask me about this one. I was just looking for people to ask very basic questions. I couldn't find any. There was a time. So you got this opportunity to be talking to people who have implemented that, who published their work on this one. So yeah, you can ask any question that comes to your mind, please. Thanks.
I've got a question, please. I'm
Go on,
very
please.
new to QCA and trying to look at adopting FSQCA for my own research. How does this work if it's a 7-point Likert 7-point scale, multi-scale, instead of a 5-point Likert scale? Does it work in the same or in a similar way where we can use the mean and the median? And yeah, that's my question.
Eva, you would want to answer, please?
Yeah, well, the principle is the same. The principle is the same. You follow the calibration rules, and you have to think of meaningful theoretical anchors when you decide the thresholds for the membership and the non-membership. Because this is the main difference of QCA, and this is why the N discussion is also maybe not so much. Maybe this is something that you can also answer the reviewers. That's not really the point. The point is the difference in causality and what kind of causality do you expect your research phenomenon has. Let's put it simply. And so if you have a 7-point Likert scale, nothing really changes as opposed to the 5-point Likert scale. You again look at your what the scale actually means, and then try to decide meaningful thresholds for your membership and non-membership, and maybe really look into what it means to have set theoretical relations as opposed to correlations and variance and stuff like that if you are more quantitative in your background, because that might take a little bit like to click to see, okay, I'm not looking at things getting more, but I'm looking at differences in kind and degree as Mohsin very accurately stated in the beginning.
Awesome, thank you.
Thank you. Any other questions we've got here?
I have a question. I have just come to this, so this is completely new, and I am a qualitative researcher. So I would be interested in how this could be used in a qualitative study.
Okay, I'll probably take a little bit of lead here, and then maybe Andres and Eva could contribute here. Jill, as the name says, it is qualitative by its very nature. In few things, even if you use it for survey research, the degree of iterations that you have to make. For example, I talked that if the calibration does not work, you go back and you examine. So to me, it has more utility in terms of for qualitative researchers, because a lot of a big challenge for qualitative researchers is that they have to explain the methodology, right? How you have come up with your studying your interview transcripts and how you've come up with this finding. So it can bridge that gap. It can be a very good intermediate step, right? Because if your paper goes to somebody who is more, operational process driven, then they'll ask these questions. Now, there are a number of ways, and I do not have as such expertise in the key thing. The only difference is, Jill, how you calibrate. Once you're able to calibrate everything, you got numbers and then you play with the numbers, exactly the reason I've described. Now, I last year I gave a seminar, and in that I did provide certain useful links of the papers who have used this for qualitative studies. I can share that with you later on as well. But quickly speaking, there are 2-3 broad approaches. One is you analyze your transcripts, and the frequency of mention of the phenomena could be one way to calibrate. Some people do, recently I saw that in general supply chain management, is that they did qualitative interviews. Based on that, they generated some questions and some parameters, and then they send it as a follow-up interview in a quantitative question. People do that as well. So there are a number of ways. And one of the things that as we move forward in this community of practice journey, is that we need to have those discussions. So if you're working on that project, so next time we meet, we can exchange ideas. So that's the whole purpose. If somebody is taking that project, because we're learning from each other, that's the whole purpose. So that's it's a long answer to a short question. But over to Eva and Andres as well, if they've got any experience here.
Thank you.
Yeah, I have not calibrated qualitative data so far, but this is like basically what is mostly done. So if you look at the publications, maybe also from other fields, I don't know what field you are in, you will definitely find examples. And if you are also from marketing management or something like that, I have an industrial marketing management paper from 2017, Sophia Torts, and colleagues with Stefan Henneberg, who publishes a lot in QCA, and they have like a template that they introduce for calibrating qualitative data. I don't know, Mohsin, if this is also one of the ones that you would have suggested. Yes. So yeah.
Thank you.
And actually, I want to learn that thing. I want to learn that thing, but I need somebody who's doing it so I can learn from that person. Yes, go on, Andres.
Yeah, unfortunately, I haven't done qualitative either. I do quantitative, but I've read a lot about it. So if you do it in the future, please share your experience. It seems to be very interesting.
Thank you.
And unfortunately, I have to leave, but I would like to thank you for organizing these workshops, and I hope there will be many more. I was trying to find the chat also to write that, but thank you very much.
Thank you very much, Andres, and we'll conclude as well. Just something before you go is that we want to make it a monthly event, and with not much formalities and with your permission. So what I was thinking is late Thursday afternoons here, so that it's morning yours, whatever. So each month, end of each last Thursday of each month, except for December, right, where we'll have Christmas break, right? So whatever progress we make, open, people come and talk and just share their experience. We can reduce the time, half an hour, 1 hour. We all are busy, but it's important that we've got this platform where we learn from each other. What do you guys think?
I think it sounds excellent, and for me, it's fine to book an hour, and then if it takes half an hour, we just leave earlier. And this timing is very good. I normally start work at 7 a.m., so it's no problem whatsoever.
Okay, with that, I think there's nothing else to talk from my side. And thanks, Andres and Eva, for especially coming at a very short notice.
Yes,
thank you very much.
Thank you for organizing.
Enlightening us with your thoughts. And we hope to see
you the same. I also learned a lot from your approach. Thank you so much.
Thank you. And we hope to meet every month from now onwards. Thank you very much, everybody.
Bye.
Thank you.
Thank you, everyone. Thank you, everyone.
And if you haven't dropped your email, those of you I don't know, please drop your email so that I can add you to the MS Team Community of Practice here. So those of you who are not still member of the Community of Practice, please drop an email in the chat section. Thank you very much, everybody. Thanks.
Thank you, Mohsin. See ya.